Hi, my name is John. I am a Cloud Alliance architect from Check Point. This is a video tutorial of Check Point integration with Aviatrix. We're going to focus on our Ingress configuration, so let's get started. Here are the high-level steps which I'll be covering in this video. So first we're going to take a look at our lab diagram, and then we're going to go ahead and start configuring our internal and external load balancers. Then we're going to configure the checkpoint security policy, followed by testing the connectivity. Now, before we dive into our lab, I want to go over the Ingress traffic flow. Having this understanding will help you with the design and troubleshooting efforts in the future. In this lab, we will be leveraging the native AWS load balancers. We support both the network and application load balancers. Configuration is about 99% the same, with some minor differences in how you define the services. We also support any third-party load balancers as well. In terms of traffic flow, we can just simply follow the numbers in the diagram. First, the users would connect to our external load balancer. Then traffic will be forwarded to our CloudGuard gateways for inspection. At a minimum, our customers will turn on the IPS module for inspection here. Our CloudGuard gateways also do a source NAT. This is to make sure that the return traffic will be routed back to our gateway to avoid asymmetrical routing. The next hop is not going to be the Aviatrix gateways, but instead the local subnet router. After we pass the traffic to the transit gateway, we'll hit our internal load balancer, then to our final destination. Now the return traffic will follow the same path, except it will go to the Aviatrix gateway, then back to the firewall, eventually to the user. This is a very scalable architecture where there is an increase in traffic, our customers can simply provision additional CloudGuard gateways or servers behind each load balancer to cater for a traffic increase. Here is a diagram of our lab. We are going to be configuring port 22 and port 80 access to our prod server, which resides on our prod VPC there. We will be creating an external and an internal network load balancer. Now, since we already provisioned 2 firewalls in our previous lab, we can just leverage the same firewalls for our Ingress connectivity as well. Before we start our lab, it's always a good idea to gather all the relevant information in one place. And what we're going to be doing in our lab, as you can see up in the first table there, we're going to traffic's going to hit our external load balancer on port 22. Our external load balancer is going to translate that packet to 5022. For the firewall to intercept, and then the firewall will then translate the port back to port 22 to our internal load balancer, and then eventually to our destination server. It's the same goes for HTTP, and then also the second table there, we're going to need these IP addresses to define our logical server. And lastly, the last table is going to be our internal load balancer's FQDN. Again, we're going to need that for the logical server that we're going to define later on in our lab. All right, let's get started. First, we're going to log into our AWS console, navigate to EC2 and load balancing and target groups. We're going to go ahead and create our internal target groups. Give it a name. Protocol, we're going to select TCP. Leave out port 22, and we need to select the right VPC. So in this case, it's going to be our prod VPC because this is where the test server resides. Okay, configuration looks good. Okay. Now we're going to go ahead and create our second internal group. And this is going to be for internal port number 80. Select again TCP service, change the port, leave it at 80, and select the prod VPC. Okay, looks good. Go ahead and create. All right, looks good. Next is we're going to configure the targets for each one of these internal groups. Go to targets, edit, and we can go ahead and add the prod server. So AWS already recognized that whatever is behind this VPC, already recognize it and give you the option to select which server. Go ahead and select save. Go ahead and select the port 80. Again, select our prod server. Go to add register. Yep, save. Okay, looks good. Okay, so next we're going to create our external target group, and we're going to give it a target group name. I like to call it external, just makes it easier to find later on. Once you start having hundreds of services, you're going to appreciate having names to distinguish what target group goes where. In this case, we're going to select our Aviatrix firewall VPC because this is where both of our firewall and external load balancer resides. We can go ahead and create the second target group for port 22, and we're going to be using the port 5022. Okay, select the Aviatrix firewall VPC. Go ahead and create. All right, so now we complete our target groups. Next, we're going to go ahead and configure the targets for our external target groups. Edit, and we're going to select our firewalls. Okay, so select both Check Point firewalls there, add to register. And we need to do the same thing for port 5080 as well. Targets, go to edit, and select the firewalls again. Oops. Select the right firewall, add register, and go to save. Okay, so now we're going to configure our load balancers. Go to load balancers tab, create load balancer, and we're going to be using a network load balancer. Give it a name, internal load balancer, and the scheme is going to be internal. Okay, we're going to add another listener. Port 22. And then in terms of the AZ, we can go ahead and configure our, this is going to be located in prod, right? So we're going to select the prod VPC. Select both AZs. Okay. That looks good. Go ahead and configure the routing. And in the routing, we're going to configure the target groups, use the existing target groups that we created earlier. Yep. And select the internal 22. Okay, looks good. Register targets. Yeah, looks good. Go to next and create. Okay. Now we're going to have to go back to modify the listeners. Okay, so if you notice that port 22 is forwarding to the right port, but port 80 is being forwarded to port 22. So we can go ahead and modify this. Go to edit and delete the incorrect target group. We're going to change it to the internal 80. Okay, select internal 80. Okay, all right, update. Cool, looks good. So next, I want to capture the FQDN of the internal load balancer. And this is going to be for our logical object later on. So we'll go ahead and copy this and paste it into Notepad. We're going to create our external load balancer. And again, we're going to use the network load balancer. Yeah, this time it's going to be internet facing. Give it a name. Okay, we're going to go ahead and add a listener. And it's going to be TCP port 22, and we're going to select the VPC, and in this case we're going to select the Aviatrix firewall VPC. This is where our external load balancer and the firewall resides. Yep. Select the AZ, and select the right subnet. We're going to choose the VPC public firewall ingress egress US West 2A. Okay, now let's select the second subnet, and we are going to select the Aviatrix firewall VPC public egress US West 2B. Okay, so configuration looks good. Go to next, and then next again. And in this page here, we're going to select our existing target group that we created earlier. Go ahead and select 5022. All right. Go to register targets, review, and create. Okay, so now we're going to have to go ahead and modify the listener, just like what we did for internal. Okay, so as you can see that 22 is being port forwarded to port number 5022, and port 80 is incorrect. We're going to go ahead and modify. Go to edit, delete the existing target group, and we'll go ahead and modify it and change it to the right target group. Okay, looks good. Okay, so next step is we're going to be configuring our checkpoint security policy. In this screen here, what we're looking at is our Aviatrix integration guide. And I won't be actually configuring these objects in our dashboard, so I was going to show you guys the screen here. You guys can go ahead and create these objects in a smart console. Okay, so once you finish the objects, then go ahead and navigate to the firewall, to the security gateway, and navigate to the external interface and modify the anti-spoofing groups. And the reason we need to do this is because remember, during the first video, the egress video, we actually defined the 10/8 route as the internal, and because of the load balancer, we'll be doing health checks to the firewall using the internal IP address, which is in the 10/8 network. You need to add all of the firewall's external interface subnets here, so that we won't be dropping the health checks from our external load balancer. Okay, so we can go ahead and log into the Smart Console, and we're going to create the logical servers. And to create that, you're going to go to the objects plane and go to New, go to More, Network Objects, More, and select the logical server. So now we're going to go ahead and reference our document, which contains all of the information there, right? So go ahead and copy the internal load balancer's FQDN, paste it in here, and put an _1, which represent the first firewall. So now we're going to put in the firewall's external IP, put in the first firewall's IP address. Okay, so once that's in, I'm going to go ahead and select the server type other, and server group. We're going to use the dummy group that we've created earlier, and the balance method is going to be domain. That's okay. And we're going to repeat the process for the second firewall as well. Logical server. Okay. Paste in the FQDN of the internal load balancer again. And in this logical server, we're going to be using the _2. Okay, and again the IP address of the firewall 2. Okay. The server group, again, we're going to be using a dummy group, and we'll be using the domain for the balance method. Press OK. Okay, yeah, just double check the work and press OK. All right, so now that we have the logical servers created. Okay, so after we created logical servers, now we're going to go ahead and create the security policy. Okay, so the source we're going to be using all internet, and for the destination we're going to use the logical server that we created earlier. Okay, select both servers there. Now, in terms of service, we're going to be using the TCP 5080 and 5022 here. If you haven't created these services, go ahead and create them now. Also, what you want to do here is that you also want to match the service as HTTP and SSH, just so that we can actually do a level of protocol inspection, even though it's running on a high port. Next, we're going to go ahead and create our NAT policy. So go ahead and add a policy up top here, that rule above, and we're going to change the source to all internet. The destination is going to be our dynamic object, local gateway external. This is something that we defined during the provisioning process of the gateway. And these actually represent the however many firewalls that we have. When the packet arrives at the firewall, it's going to know that it's referring to the external interface. So we can go ahead and define the internal, and we're going to change the NAT type to a high NAT. Okay, looks good. And we're going to change the translated service to port 80. Going to be the HTTP service here. Okay, so that's our first rule. Go ahead and create another rule at the bottom there. Okay, so it's going to be the same, right? Local gateway external, and this time we're going to change the original service to 5022. This is where the load balancer translate the port 22 to 5022 to a firewall, and then the firewall then translate that back to the port 22 and force it on to the internal load balancer. Okay, so the NAT rule looks good. Now that we have our security policy and the NAT policy, we're going to go ahead and install the policy. Okay, policy push complete, and we can move on to the next phase, which is going to be testing the connectivity. Okay, so to test connectivity, go back to our policy, and as you can see, we're already seeing log entries showing up. Those are probably coming from the external load balancer health checks. And to test, what we're going to do is that we can copy our external load balancer's FQDN, right, which is the DNS name here, and we're going to paste it into the browser. So what's going to happen is that load balancer will intercept our traffic and force it to the firewall at 5080, and then the firewall then sends it to the internal LB. And as you can see, we can hit our internal web server. Okay, so next is I'm going to go ahead and try to SSH to the server. And it looks like I have the keys here, so that's good. Okay, again, use the external load balancer's DNS name, and looks like I'm able to connect to the server on port 22 as well. Just run a couple commands, make sure I'm on the right server. Yep, looks good. I'm on the right server. So it looks like we have connectivity. So that concludes our Ingress how-to video. We've gone through our lab diagram, configure our internal external load balancers, configure our security policy with NAT rules, and also test the connectivity. Thank you.